Hello, I'm Pavel, Bob's AI assistant, and I want to take you on a journey through the future of logistics, one that's modular, intelligent, and sustainable. What if every container carrying your phone, laptop, or graphics card could think for itself? What if it knew its route, tracked its own condition, and rerouted around delays, all while reducing emissions? That's the world we're moving toward, and it's called the physical internet. This deep dive explores how smart containers with IoT sensors and predictive analytics can transform the way we ship high-value goods. Despite decades of advancement in global trade, today's logistics systems still face fundamental inefficiencies. Trucks often depart warehouses only partially loaded, resulting in what are known as empty miles. This means a significant percentage of transport capacity is underutilized, increasing fuel consumption, emissions, and cost per shipment. Based on studies from Our World in Data and Statista, these inefficiencies have a substantial environmental impact. The transportation sector accounts for approximately 14% of global greenhouse gas emissions, with road transport contributing around 75% of that total. This means that road freight alone is responsible for over 10% of global emissions. Addressing underutilized trucks, outdated tracking, and fragmented networks isn't just a matter of cost. It's critical for reducing the environmental footprint of modern logistics systems. Uber Freight's research from 2023 estimates that empty miles comprise about 20% to 35% of U.S. trucking miles. Furthermore, companies continue to invest in high-tech goods, products that are fragile, time-sensitive, and immensely valuable, yet they're often moved through supply chains without proper visibility, or are manually tracked using outdated systems. This brings us to a new paradigm, the physical internet, a globally connected, modular, and intelligent approach to moving goods. Inspired by the architecture of the digital internet, the physical internet envisions a world where logistics systems are built on standardized, interoperable modules, allowing freight to move through a decentralized, open network of hubs, vehicles, and warehouses. Instead of isolated operations, companies share infrastructure and routing capacity. Goods flow collaboratively, as if they were data packets moving through the internet, dynamically routed based on real-time conditions, demand, and resource availability. At the core of this system are smart PI containers, modular, sensor-equipped units that can communicate, self-monitor, and integrate seamlessly with cloud-based logistics platforms. These containers enable transparency, traceability, and intelligent decision-making across the entire supply chain. They are active, intelligent assets within a larger cyber-physical network. Constantly aware of their environment, they interact with platforms that make decisions in real time, transforming how logistics is managed. These containers continuously transmit information, from location and route progress, to internal temperature, humidity, and even vibration levels. For industries like pharmaceuticals and electronics, where even slight deviations can be critical, this data becomes invaluable. This isn't a distant vision. Ports and logistics hubs around the world are already piloting these systems. Companies are investing in smart containers and real-time visibility platforms to boost performance and resilience. Instead of rigid schedules, containers are pooled, pre-sorted, and dispatched using real-time data. Cross-docking and consolidation are seamlessly integrated. By integrating AI and predictive analytics, smart logistics systems can analyze patterns. Logistics platforms can forecast disruptions, reroute containers instantly, and trigger alerts before cargo is compromised. If a road is blocked, the container sends data to reroute, keeping the supply chain moving. Each smart container becomes a node in a broader logistics web, collectively optimizing the system through intelligent interaction. It's no longer about one shipment. It's about an orchestrated flow of information and goods. Predictive analytics also extend to the containers themselves. Wear, shock, and humidity data can indicate when units require maintenance, avoiding breakdowns and minimizing costly delays. This intelligence is key not just to efficiency, but to sustainability. With smarter routing and fuller loads, we cut CO2 emissions, idle time, and waste. But how do we move from theory to measurable results? To explore this question, a simulation was built using AnyLogic, a powerful platform for modeling complex systems, from supply chains to traffic networks. Two scenarios were built. one with companies operating independently and another using physical internet collaboration, with shared shipments and optimized routes. In the first, companies operated independently. Each shipment was handled separately, trucks ran on fixed routes, and there was no coordination between distribution centers. You can see it here. Yellow icons represent warehouses. Green ones are retail destinations. In the second scenario, physical internet collaboration was introduced. Companies shared shipments, with goods first consolidated at one warehouse before being jointly delivered to retail locations. The flow remained structured, but now resources were used more efficiently. Routing was optimized between modular containers using principles of the physical internet. Shipments were pooled, and empty space in vehicles was reduced. Results were analyzed using Excel and Power BI, comparing total kilometers traveled and CO2 emissions. The collaborative model consistently outperformed the traditional one, reducing both distance and environmental impact by 32%. Simulation proved that collaboration, real-time data, and modular smart containers aren't just theoretical improvements. They're a practical path forward, a way to make logistics faster, cleaner, and more efficient. And while challenges remain, the direction is clear. To validate the findings beyond simulation and explore real-world feasibility, an interview was conducted with Seppo Naarinen, co-founder of Contai and the SLP Alliance. A recognized pioneer in modular logistics and urban physical internet systems, Seppo confirmed the direction is promising, but not without its challenges. Among the biggest barriers, high implementation costs, a lack of standardized systems, and an industry culture often resistant to collaboration. Yet the work being done by innovators like Contai proves transformation is possible. From autonomous load carriers to open modular interfaces, these technologies are already being tested in demanding conditions, including defense and Arctic logistics. The insight is clear. The physical internet isn't just a vision, it's a realistic path forward. But this path demands more than smart tech. It calls for shared infrastructure, interoperability, and above all, trust between actors. Logistics won't evolve through software alone. It evolves through cooperation, transparency, and a commitment to smarter systems. The future of logistics is not just connected, it's shared. And real change doesn't happen overnight. It begins with one decision, one company, and one container at a time. Thank you for watching.